Right. Good morning, everybody. Before I do my official start, a couple quick things that I'm going to cut out of the video. You should have gotten from COD an email for a link, I think. I don't know, I've never done it myself personally, to do evaluation of me in Chem 1105. Could you please fill it out? Also, if you really like what I've done this semester, go to ratemyprofessor.com and tell them about it, everybody about it. If you really didn't like what I did this semester, go to ratemyprofessor.com and tell everybody about it. Now, if you really like what I did this semester, send an email to the Board of Trustees, copy the president. They do read them, and tell them what a great job I did. If you really didn't like what I did this semester, send an email to the Board of Trustees and copy the president of COD. I believe I have on my website, or I'll send out in an email, those two email addresses. But please fill out the course evaluation from COD and also ratemyprofessor.com if you like what I did or didn't like what I did. All right, let's get going. Important day today. Right after I finish lecturing today, I will send out the password email for your version of test number 4. Test number 4. You'll have until 11:30 today to take test number 4 and upload your answers. Let me remind you, at the back of test number 4, there is, I didn't do my official good morning greeting. I'll have to do that. Let's start again. Good morning, everybody. Welcome to another exciting morning of Chem 1105 with your host, me, Dr. White. And don't forget, today, right after lecture, I will be sending out the email with a password for your version of test number 4, which you can download if you already haven't from Blackboard. You'll have until 11:30 today to take test number 4 and upload your answers. All right. Next, don't forget today, I think it's 9 p.m. tonight or 8 p.m., is the deadline for the extra credit project. It's optional. You don't have to do it, but if I were in your shoes, I'd do it because it's 10, yes, 10 points. And that's like getting 10 more points on any test or the final. So 10 points, and you still have plenty of time to do it. It doesn't take that long to do it. Tonight, I will be having my office hour from 5 to 6. If you need help with your extra credit project, stop by and I'll help you. And that's it for the extra credit. All right, later today, I will be posting the the points breakdown information about the final exam. Yes? The answer is Disha, yes. I'll talk about that in a second. I will be posting and sending out an email to each and every one of you the details about the final exam, which is a week from today. Boy, where does summer go? When time flies when you're having fun with chemistry and Dr. White, I hope. But anyways, this last week. But anyways, I will be posting that later today. Also, tomorrow, I will be going through test number 4 answers. Yep, because my other class ended last week. We started a week earlier at Elgin Community College. I have this afternoon to able to work on grading your test. I knew that. That's why I didn't have it Thursday. I had it today. And I will also, by tomorrow morning, be sending out the individual answer uh, or points for each answer on test number 4 that you did, so you know what you got right and wrong, like I've done all semester. But tomorrow I will go through test number 4 answers. I will cut it out of the, how do you like my scissors? Works good. Cut it out of the video like I've done all semester. Also, labs. This weekend, yesterday, good part of the day, I went through and caught up on all labs. I would highly recommend that you go to Blackboard today or tomorrow and look and see if you've handed in a lab and you don't have a score. Somehow I missed it. I went through all my emails. I went through all the uploads for assignments. I think I caught them all, but last time I checked, I don't walk on water unless it's frozen. Even then, I stay off it. So if I miss the lab you've turned in, let me know and I'll grade it. I will give you an extra amnesty. You have until Wednesday to hand in any late labs. Because it's just about the end of the semester and I'm going to be quite busy. So if you haven't handed in a lab, you better get it in by Wednesday. Let's make it 8 p.m. Wednesday, 8 p.m. is the final deadline for labs, except for the one we're doing tomorrow. In fact, even then, if you can get it in by Wednesday, tomorrow's lab, I'd appreciate it. But tomorrow's lab deadline is Thursday, sometime, say 1 p.m. Thursday. That gives you plenty of time. It's a quick lab to do. All right. Any questions so far? Again, get your check and make sure I've graded all your labs. If not, email me. Also, don't forget, right after we finish today, and it's going to be a quick lecture day because I only have one more topic. I thought I'd throw in a story too. All right, let's get to work. All right, last chapter. This will not be on test 4, but a question or two will be on the final exam. Thumbs up, people, help me out. Oh, one other thing before I start this. Oops, thank you. Before I start this, one of the reasons my students do always do good on my finals are this week, starting probably Wednesday, but I might do a little tomorrow, but Wednesday for sure, Wednesday and Thursday, I will do a review for the whole semester. Yep, the whole semester, both days, and it helps students do good on my final. So be sure to show up for my review for the whole semester. How do you like that? Never mind, whole semester. Be sure to show up. All right, let's go through radioactive nuclear radiation. Now, when we talk about nuclear radiation, we're really talking about radioactive elements. And the switch is off for this slide. I'll tell you what things you have to know, like I've done all semester, when we get to it. Now, a radioactive element is an unstable isotope of an element that will emit energy spontaneously to form a more stable isotope. Remember, isotope elements have the same number of protons and electrons, but they're different isotopes, and the isotopes differ by the amount of neutrons. And certain elements have unstable isotopes that give off a lot of energy to form a more stable isotope. And what is this energy? We call it radiation. Radiation is the energy emitted from a radioactive isotope. Switch was off on this slide. Now, next couple of slides, click, switch will be off, but I still want to cover it. Now, there are different types of radiation. If you're a nuclear chemist, they came up with names for different types. One type is called the alpha particle. Alpha is the Greek letter that looks like that. And alpha, a particle that contains 2 protons and 2 neutrons, is called an alpha particle. It's emitted from a radioactive nuclei, which is what name they use for uh, isotopes of nuclear radioactive material, and it has a positive charge. 2 protons plus 2 neutrons, no charge. So that's an alpha particle. Now, there's something called the beta particle, which is a Greek letter. Beta looks like a B, but it's a beta. It's a particle whose charge and mass are identical to electron and is emitted by a radioactive nuclei. Now, I'm not a nuclear chemist, and I always wonder, why don't they just call it an electron? But they didn't. And it's called a beta particle. And it has a negative charge. Now, positron is a particle produced by an unstable nucleus, and it has a positive charge. What's the difference? Well, I guess 2 neutrons. Why don't they call it a proton? And I think they do if you listen to commercials about proton cancer treatment. I think that's what they're talking about. Positrons. I don't know, so don't quote me on that. Now, if you have something that's pure energy, we call that a gamma rays. And gamma rays are formed, again, switches off, a form of high energy radiation without mass or charge and is emitted by radioactive nuclei. How can energy have no mass or charge? Well, just look at any light. That's got energy and has no mass or charge. And gamma rays are quite lethal. However, in our universe, gamma rays will not turn you into the Hulk unless you're Bruce Banner, I guess. But no, they'll kill you, but they won't turn you into the Hulk. For those who don't know the legend or the story behind Bruce Banner and the Hulk, I'm sure it's somewhere on the internet. By the way, when I was younger, yes, I was addicted to comics and comic books. I was more a uh, mixture DC and Marvel. My all-time favorite was Thor. In fact, I'm probably one of the few people you know who has a book of the Prosetta, which is the epic poem telling about the Norse gods and Norse mythology. Excellent reading. All right. Now, there's something called radioactive decay. Switch is still off. That's a process where a radioactive nucleus is transformed into a nucleus of another element, meaning another isotope or element itself, as a result of the emission of radiation. And as I mentioned, the types of energy that can be emitted are alpha, beta, or gamma rays. I guess alpha, I should really have alpha particles, beta particles, or gamma rays. So this is called radioactive decay. And when this happens, it gives off a lot of energy, radiation energy, which can be harnessed in the form of heat. All right, how many of you are familiar how a nuclear reactor works. You have radiation, the rods or whatever, and they heat up water because of the heat from the decay, the energy given off from radioactive isotopes. You can heat up water. Heat it up to what? Steam. By the way, click, switches off, but it's still something you should know. Now, the steam has energy or pressure, and it can turn turbines. Those are wires around magnet with magnets surrounding it, and that creates electricity, which is how in Illinois, I think 50% or more. Let me look up. Let's look up. As of 2020, I don't know if you can see this or not, about 60% of the electricity is generated in Illinois by nuclear reactors, which 5% of the total in all of the United States. That's a lot. But anyways, let's do one more. All right, thumbs up, people. First of all, let me check. All right, do you see in the left part of your screen the pressurized water reactor? Thank you. And here in this dome gray area, you have the nuclear rods, and they heat up water, which heats up more water that turns a turbine right here. Let's see if I can get it bigger. Yep, I got it bigger. And this makes electricity. Now, the problem is these rods that are highly radioactive. After a while, the radiation decays and they're no longer useful to make energy this way, electricity, but they're still highly radioactive. So what? What's the problem? Well, let's find out what the problem is. All right. Everybody see half-life of a radioisotope on your screen? Thank you. All right. Now, half-life of a radioactive isotope. Click. The switch is full on. If it was a dial that goes to 10, I've just turned it to 15. You should know this, not for test 4, but for the final exam. Now, there's something called the rate of decay, radioactive decay, and this is called the half-life. The half-life is abbreviated by letter T, subscript 1/2. And it's the amount of time that is required for 1/2 of any given quantity of a radioactive substance to undergo decay to something that's not radioactive. So think about that. Anything that's radioactive, like radioactive waste, the half-life is the amount of time that it takes half of the material that you started with to be not radioactive. Now, let's look at some common materials. Now, for uranium 238, the half-life is 4.5 billion years. That means if you have a ton of 2,000 pounds of uranium 238 today, 4.5 billion years from now, you'll have 1,000 pounds, half a ton. Now, if you have uranium 235, well, it's a lot quicker, only 700 million years. Now, if you have uranium isotope 234, that's real quick, 25,000 years. Now, let's talk about this. First, then I'll show you how to calculate for something. Well, if we're generating all this waste from uranium power plants and also plutonium, and it takes thousands of years for that material that's waste but still reactive, radioactive, to decay, what do we do with all that waste? It's going to be around for thousands and thousands of years. No chemist, and I've thought about it myself personally, but it's not my area of expertise. Nobody has found a reasonable way to take something that's radioactive and make it non-radioactive quickly. They haven't found a way. If they do, you're going to be really wealthy because we've got lots and lots of waste. Now, the government, and let me first talk about one more thing. Plutonium 239, which is an important waste, I don't know if you see it on your screen right now, has a half-life of 24,000 years. That means if you had 1,000 pounds today, 24,000 years from now, you only have 500. And that's the problem with nuclear waste. Now, let's look at the following. Oops, I forgot. You people don't know cursive. 2 days later, I'll finish. All right, let's go through this. If you have 400 grams of studentium, you didn't know Dr. White could make up his own nuclear L isotopes. I can. With a half-life of 2 days, then how much studentium will you have after 6 days? Now, there's a complex formula you can put this in, but if I make it simple for you, there's a simple way. Now, you're trying to find and it has a half-life of 2 days. And let's say The atomic symbol for studentium is Sg. And here you have 400 grams. After 2 days, you'll have half of that, 200 grams. After 2 more days, you'll have half of this, 100 grams. And after 2 days, which is a total of 6, you'll have 50 grams. And that's the easy way to do this, as long as I give it an easy multiple, which I will on my test or final. Yeah. So the correct answer here is 50 grams. Same question. But new compound. (1105 That's a new one. And you have 800 grams and a half-life of 1 day. How much will you have after 2 days? Your turn. You try this. When you're done, it's time for give me a thumbs up if you can. Ooh, I see a lot of thumbs up. All right, I think everybody's done. Let's do this. All right, so we have 800 grams of 1105 PM. How is that hokey? But it's funny. And it has a half-life of 1 day. So at the end of 1 day, you'll have half of that, 400 grams. But we're supposed to find out after 2 days. So we now have, after 1 day, 400 grams. And after the second day, 1 day, which is 1 plus 1 is 2, you'll have half of that. And the answer is, after 2 days, you'll have 200 grams of 1105 That cracks me up. It's so bad, it's funny. But anyways, you should know this. And that's part of the problem, the half-life of different radioactive elements. Now, a number of years ago, I think around 2010, give or take a couple of years, the federal government, someone came up with an idea. Let's take all the waste from the United States and store it in one safe place that will be safe for thousands and thousands and thousands of years. And for some reason, they decided on these mountains near Las Vegas. Good job. You know, let's gamble on blowing up the country near Las Vegas called Yucca Flats Mountains. Now, they spent a lot of money digging caverns in this rocks underneath the mountain because it was quote unquote a stable area geologically, even though it wasn't. They do have earthquakes there, you're right. And switches off. They started building this nuclear waste depository, which thumbs up, people. Do you see that on your screen right now? You should. But anyways, they spent a lot of money. Well, one, they had a lot of opposition, like people in Nevada. Why should we get stuck with all your waste? That was the first thing. The second thing is, how do you store something that might have to be stored safely for 50,000 years or maybe longer, 20,000 years? Well, they came up with these containers, waste storage, that they could put the drums of the waste, liquid waste, and they had others for fuel rods, protect them for all this time. And they tested them. After about 2, 3 years, guess what? They started leaking. And here's something that's supposed to last for thousands of years. Within a couple of years, what a waste. Well, government wasted I don't know how many millions or billions of dollars on this. Finally, they just gave it up because of the opposition and the fact it wasn't feasible. But now, at various nuclear plants, like here in Illinois, not to scare you, but it is scary, they have pools of liquid water or water to protect it, of spent fuel rods, radioactive stuff that's just been accumulating, and they have no way of knowing how to get rid of it. Which is why, thank goodness, the United States is slowly moving toward wind and solar power because you don't have that waste problem. And same thing with coal, where you're polluting the atmosphere, or even with scrubbers, you're still causing problems. All right, switches on. Now, when we talk about nuclear radiation and making energy, and unfortunately also making weapons like the nuclear bombs, we have two types of ways of doing that. One, and you should know this, one is called nuclear fission. And what is fission? Nuclear fission is the process in which a large nucleus, like uranium, is split into two smaller medium nuclei, and it releases a large amount of energy plus some neutrons. And this energy can be used for A, making electricity, or B, as what happened in Japan, as a weapon of war to kill. And nuclear fission was the first atomic bomb dropped on Japan. And it used uranium, I think 235, but don't quote me on that. But you should know nuclear fission, large nucleus to smaller ones. And you should know the main use in our country right now are our nuclear reactors for power. You should know this. Oops, wrong thing. Right thing. And you should know this. Nuclear fission, large nucleus to smaller ones. Most important thing you should know is an example of nuclear fission is a nuclear reactor for electricity. Like I say, and you should know this. Now, the other type of way of creating energy through nuclear reactions is nuclear fusion. And you should know this. And nuclear fusion is the process in which small nuclei are put together to make larger ones. And the biggest example is that's what happens on the sun. Now, how do I remember these? I think of U in fusion is U in sun. Don't ask me why it works, but it works well for me. And if you happen to look at the sun with proper eye protection, what's happening? Hydrogen nuclei are coming together by strong gravitational forces are slammed together to make helium. And when this happens, it gives a tremendous amount of energy, which is our sun. So next time you're outside walking in the sunlight and you feel that heat from the sun, that is nuclear fusion. So let's go through this again. Fission, that's large nuclei going to smaller ones. It's found in our nuclear reactors for electricity. Nuclear fusion, the U helps me out. That's the process where two small nuclei or atoms are slammed together, put together, make larger one, and lots of energy. And that's what's happening on the sun. U in fusion reminds me of U in sun. And with that, new material, we're done for the semester. Yay! Not really. We got a lot more work to do this week, so you do well on the final exam. Now, quick question. Did I teach you, give me a thumbs up, or, oh, better yet, I'm going to do the polling. That wrong thing for polling. Even though the question asked, are you done? Let's do a different question. Did I teach you how to clean a bathtub quickly? Answer yes if I did, no if I didn't. 50-50. All right. I'll do it again because we got a couple minutes before I'm going to call it a day and send out the password. All right. One of the things probably the thing I hate the most around my house is cleaning my bathtub or the shower store. I don't use my shower stalls downstairs. I use my bathtub for my showers, and I use bar soap. And after a while, you know how you have that icky, yucky crud? Isn't that scientific? Icky, yucky crud that's on the walls, otherwise known as bathtub scum, scientific. And you know how you got to scrub and scrub, especially like me, if you let it go too thick because you don't want to do it. Oh, I finally have to do it. Well, I challenged myself a number of years ago. Hey, you're an organic chemist. What's this bathtub scum and how do you get rid of it quickly? Well, it turns out, and the switch is totally off for this, other than it will help you out personally. When you use a soap, if you use bar soap, and this is the worst, you have this ionic compound. It's called sodium taloate. And in your water are calcium and other divalent +2 charge cations. If you have hard water, it's even worse. But here, even in Chicagoland, Lake Michigan does have that. And that does an ion exchange to make this, and that's your bathtub scum, mainly. Now, the question is, how do you break that down? I'm looking at that and say, oh my gosh, take an acid and that will do that. Well, you're not going to use sulfuric, nitric, or hydrochloric acid in your house. No. However, you do have vinegar, but vinegar is very weak. It's about 4% acetic acid. So I was thinking, how do I find a stronger acid that's safe to use in the house? And lo and behold, I don't know how I found out about it. I hadn't been using it, but there's a product you can buy anywhere called Barkeeper's Friend. So everybody's, let me check and make sure you should all see pictures of a gold can or a bottle on your screen now. That's Barkeeper's Friend. I buy those solid powder. You can buy it at Jewel, Osco, or Jewel. You can buy it just about anywhere. Uh, Walmart has it. I haven't looked for it in Target, but I bet they have it. My local grocery store, Valley Produce, has it. And I use it. Now, what is Barkeeper's Friend? It's a mixture of soap and an acid, a strong acid called oxalic acid. And the oxalic acid breaks down, just like I showed you. In organic chemistry, we use H plus, meaning an acid. And it breaks down something that's more water soluble. So how do I do that? Simple. In my upstairs bathroom, right outdoor and around, anyways, my house, I have one of those removable shower heads. I turn it to hot water, take the shower head, spray down my walls and the whole bathtub area with hot water. Then I take the Barkeeper's Friend and sprinkle it on there, and with a paper towel, because sponges get fouled up real quick with this. Use a good paper towel that's slightly moist. I just rub it on there lightly like this, sort of like make a paste over everything. Then I wait 10 minutes. The rubbing down takes about 2 minutes, the whole bathtub and everything. You're not trying to scrub it, just make a paste over everything, especially that's dirty. Now, after 10 minutes, if you have a light scum, take a new fresh white paper towel on the paste, just give it a quick rub off like that, and then you can spray it down and it's gone. If it's real thick, like I have sometimes, take a little, the green 3M scouring pads. I've learned you can cut them into fours so you don't waste them all. Take a small piece, put a little Barkeeper's Friend, a little water, and just go like this. And I can do a bathtub, my time wise, actually working about 10 minutes or less. The actual time from start to finish, about half hour, maybe less even. And after you finish scrubbing or cleaning, you take your shower stall head, I do, or you can use small bucket of water, and you spray it and it all goes down into your drain and you're done. And it works really good. Also, Barkeeper's Friend, because it has the acid in there, oxalic, will break down things like in my baking pan when it has grease or stuff in there after baking. pour some, wet it, pour some in, make a paste, come back 10 minutes later, boom, it scrubs right out with one of those 3M with hardly any scrubbing. And with that, that's my tip of the day, end of week, end of semester. And with that, if I look at the clock, I'm going to end now. Remember, in about 5 or 6 minutes, I will be sending out the password for test number 4. Also, I'm going to experiment. I think I'm going to turn off just temporarily my 1105 YouTube channel. I want to try that. Remember, there's a lab due tomorrow, and we'll have a lab tomorrow. We'll have tomorrow beginning. I will go through test number, a couple questions. I'll answer your questions in a second. I'll go through test number 4 answers. Now, someone just asked a quick question. How many on problem? All right, thumbs up, people. Do you see my announcement for test 4? To answer the question one of your colleagues just asked, there's 17 problems now, 9 pages, no multiple choice. There's 5 bonus points. So make, one other thing. Happened last test. Make sure before you upload the test, you look at your PDF file. Make sure you've scanned in all your answers. It happened to 2 people, and I was nice enough to contact them and say, you forgot to upload this, but I might miss it. No, I don't think I'll miss it, but make sure you check that you have all your answers for all your questions for test 4 in your PDF file before you upload it. Now, the other question one of your colleagues asked, how many labs do we have left? Tomorrow is the last lab. On Thursday, if we were face-to-face, we'd have what's called checkout. But we're not doing checkout because you didn't come to the lab to work in the lab with you. We check out, and what checkout means is each groups of 2 students are given a signed a drawer with equipment in it, and I come around, check, and you tell me, do you have all your equipment? Something's missing or got broken, I replace it. So next semester, when we're face-to-face, which we're not this year and won't be next semester, that is all there. However, this Wednesday and Thursday, I'll be able to spend time on review. Now, one thing, no, I shouldn't have had a V8. I forgot. And that is tomorrow after the lab, for those who want to stick around, for those who didn't do good on test number 2, I will go through the 3-step balanced equation mass reaction question. Hint, you should know how to do that. I'm not going to say any more. And with that, I'm going to say gang gesund. I'm going to go in a little while and send out the password for test 4. And you take it, upload it by 11:30, unless you have prior permission, if you have a blue card, to hand it in later. But everybody else, 11:30, get it in on time. And with that, I'm going to say, gang gesund, goodbye, be healthy. It's getting wicked out there. Make sure you wear a mask. And if you haven't gotten your shots for vaccination, get them. They're free. They're easy to get here in Chicagoland, and it will save your life. And with that, I'll say once more, gang gesund, bye.